You know that feeling, right? You're out there under this amazing dark sky, telescope ready, your heart's kind of buzzing, thinking about what you're going to see.
Yeah.
And then, well, maybe the image is just frustratingly dim. Or you just cannot find that faint, fuzzy thing you saw on the chart. It happens. That initial excitement can kind of, fizzle out when you struggle to actually see stuff or even point the scope right. But what if I told you you don't necessarily need a bigger telescope to fix that? What if just a few key add-ons could unlock way more from the scope you already have? Welcome to the deep dive. Today, we're on a mission. We want to demystify telescope accessories. We've gone through a ton of material, articles, notes, user experiences to pull out the stuff that really makes a difference, the things that will genuinely transform your nights out there, make it less frustration, more, well, awe.
That's exactly it. So many people start with a perfectly good entry-level scope, and that's fantastic. But what often gets missed is how just a few well-chosen accessories can massively boost that experience. This isn't about just buying more gear for the sake of it. It's about smart choices, Things that really improve clarity, comfort, and honestly just the fun of looking up. We're boiling down the key insights for you, helping you get the absolute most out of your time exploring the cosmos.
Okay, let's dig in, because the first thing on our list, it seems almost too simple, but the sources really hammer this home. A red light headlamp or flashlight. I mean, we're talking telescopes, galaxies. And the first recommendation is a basic red light. What's the big deal? Why red?
The big deal is night vision. It's everything when you're trying to see faint things. See, your eyes need time, maybe 20, 30 minutes to fully adapt to the dark. Really sensitive, and a quick flash of white light. Boom. It resets that process. You're basically starting over. Red light, though, it's different. It has longer wavelength. It doesn't blast those super light-sensitive cells, the rods, in the same way. So your pupils stay open, your dark adaptation stays intact. It's absolutely crucial for seeing those faint fuzzies, those dim galaxies, a total game changer.
Okay, so it's about protecting that adaptation. Makes sense.
Exactly. And the sources really push for a headlamp specifically. Think about it. You're out there, maybe fiddling with the focuser, swapping an eyepiece, checking a chart, trying to hold a flashlight at the same time. It's awkward. You drop things.
Yeah, been there.
A red headlamp just frees up both hands completely. Which sounds minor, but it really reduces the hassle. You're not thinking about juggling the light, you're thinking about observing. It keeps you in that flow. That's why it's often called like the first good investment to make. Simple, but high impact.
Right, so it's not just seeing your stuff, it's preserving the dark vision and making the whole process smoother. That's a big shift. Are there any, downsides? Can you have too much red light? Or a wrong kind?
That's a fair point. Some really cheap ones can be surprisingly bright, actually. Or have a really focused beam when you just need soft ambient light. The idea is just enough light to see what you're doing right in front of you, not to light up the whole area. So look for ones with adjustable brightness. Dimmer is usually better. Subtle utility, Not a spotlight.
Gotcha. Okay, so night vision preserved, hands are free, we're ready to find something amazing. But that leads to the next big hurdle, doesn't it? Finding the thing in the first place. Because, let's be honest, a lot of starter scopes come with finders that are difficult to use, uncomfortable, or offer a poor viewing angle. It's like trying to pinpoint a star through a keyhole sometimes.
Exactly. You've nailed the frustration. Pointing the telescope accurately is fundamental, and the stock finder is often, the weak link. Our research really points to two main upgrades here. A good red dot finder, or the sort of classic, the tried and true Telrad sight. They offer different ways to navigate, but both are vastly better than the basic finders.
Okay, red dot finder. How does that work?
Think of it like projecting a small, harmless red dart onto the sky. Wherever that dot is, that's exactly where your main telescope is pointed. Dead simple. You can get decent ones, like from Barda, for around $35 or so. They often give you a much more comfortable viewing angle than craning your neck into a tiny optical finder. Plus, they usually come with different mounting bases, so they fit on lots of different telescopes. Very versatile.
And the Telrad. I've heard that name a lot.
The Telrad is super popular, usually around $50. It doesn't just project a dot, it projects 3 glowing circles onto the sky, like a bullseye. These circles represent specific angles, 4 degrees, 2 degrees, and half a degree across. It gives you a sense of scale against background stars. This makes star hopping, jumping from bright known stars to your target much, much easier. You can visually frame your target area. And importantly, its brightness is adjustable, so you don't have that issue of the reticle being too bright and washing out faint stars nearby, which some cheaper red dots can do.
Okay. So One's like a precise pointer, the other's more like a targeting map projected onto the sky.
Pretty much, yeah. Both make finding things way less of a chore and more, part of the actual observing process. It removes a huge frustration point.
That really does sound like a game changer. Makes your time actually looking through the scope more rewarding, less searching. I've heard folks really prefer one over the other. Is it just personal taste, or is one better for certain things?
It often comes down to preference, yeah, and maybe how you like to observe. Red dots are maybe simpler, quicker for just pointing at bright stuff. Telrads with those circles really shine for star hopping to fainter objects. That visual scale helps a lot, honestly. A lot of experienced people end up using both. Telrad for the general area, then maybe a smaller optical finder, or even a red dot for the final zeroing in.
Oh, interesting, like having the big map and then the magnifying glass.
Exactly.
Okay, right. Now, here's where things get maybe a bit more technical, but really clever. What if you could basically double or even triple your magnification without buying a whole bunch of new eyepieces? Let's talk about the Barlow lens.
Yes, the Barlow. What's really striking about the Barlow lens from the research is just how versatile and cost-effective it can be. Its main job is to increase your telescope's effective focal length. Think of focal length as the scope's built-in zoom power. Longer focal length equals higher magnification. So a Barlow lens slots in before your eyepiece and acts like a multiplier. A 2x Barlow doubles the focal length. A 3x triples it. And because magnification depends on the telescope's focal length and the eyepiece's focal length, doubling the scope's effective focal length means you double the magnification of any eyepiece you put into it.
So wait, if I have a 10mm eyepiece.
Right, if you put that 10mm eyepiece into a 2x Barlow, boom, it performs exactly like a 5mm eyepiece would in your scope. Higher power, same eyepiece.
Wow, okay. That suddenly makes your existing eyepieces way more flexible.
Totally. It's especially useful for things like planets or the moon, where you often want higher magnification to see surface details, clouds on Jupiter, Saturn's rings, that sort of thing. It effectively expands your eyepiece collection without the cost of buying several individual high-power eyepieces. And there's another angle too. A decent Barlow, maybe 25, 30 pounds, often has something called a T-thread.
A T-thread?
Yeah, it's a standard screw thread. It means you can often attach your DSLR camera or dedicated astronomy camera directly to the Barlow. This not only magnifies the image for photography, but can sometimes actually help the camera reach focus if your telescope setup makes that tricky otherwise. It's also interesting, many really high-end, expensive eyepieces, they actually have Barlow-like lens elements built right into their optical design to achieve your performance.
That's fascinating. So it's a really smart, budget-friendly way to get more power, especially for planets, and even dip your toes into astrophotography. But I guess the question is, if it's simulating a higher power eyepiece, are there trade-offs? Is it quite as good as a dedicated 5mm eyepiece, for example?
That's a really sharp question. And yeah, there can be differences. A good quality Barlow will add very little, if any, noticeable degradation to the view, but a cheaper one, it might introduce slight optical errors, maybe soften the image a tiny bit, reduce contrast, you're adding more glass into the light path, right? Every extra lens element can dim the image just fractionally, which you might notice more at really high powers. So while a good Barlow is fantastic value and incredibly versatile if you find you're always using one specific high magnification, well, a dedicated eyepiece designed just for that focal length will usually give you the absolute sharpest, brightest view. It's that classic trade-off. Maximum versatility versus ultimate optical perfection for one specific task.
Okay, that makes total sense. Quality definitely counts, even with accessories. Which actually leads nicely into eyepieces themselves. Because Barlow gets more from the ones you have, but sometimes you just need a better window onto space, right? Our sources kept pointing out that the standard eyepieces you get with a lot of scopes, usually like a 25mm and a 10mm, they're often pretty basic. Narrow field of view.
Yeah.
Maybe not that exciting.
Exactly. This is about the quality of the view, the experience. Are you getting the most immersive picture possible? Investing in some additional eyepieces, maybe with different focal lengths for different magnifications, but crucially, with much wider fields of view, say 68 degrees or more, that can utterly transform your viewing. Instead of feeling like you're looking through a narrow tube like a peephole, suddenly it feels more open, more comfortable, like you're actually in space.
Like going from standard definition to HD, maybe.
Or maybe like upgrading from a small porthole to a giant panoramic window. It just feels less confining, much more immersive. That's the word that comes up again and again.
Immersive.
Immersive.
I like that. Panoramic window.
And having that range of eyepieces, different focal lengths, means you can optimize the view for whatever you're looking at. You might want a low-power, wide-field eyepiece to take in the whole sweep of the Pleiades star cluster or a big nebula in context. Then you switch to a higher power, maybe still reasonably wide field one, to zoom in on the details of a planet or split a double star. That flexibility is key. And here's the other great thing. Eyepieces are usually a really good long-term investment. Unlike maybe your first telescope, which you might upgrade later, good eyepieces, they'll usually work with your next telescope, and the one after that. Standard sizes, 1.25 inch or 2 inch. So quality eyepieces hold their value and grow with your hobby.
That's a fantastic point about the long-term value. And yeah, that idea of immersion, making it feel less like looking at something and more like looking out, I could see how that would be huge.
Yeah.
Okay, so we've got great eyepieces, maybe a Barlow, a good finder, red light. But what about those nights? Those chilly, damp nights. We've all had it happen. You're finally set up, you've found your object, the view is perfect, and then your lens fogs up with dew. Game over. It's so frustrating.
Oh, dew, the bane of observers everywhere, especially in certain climates or seasons. You find that perfect galaxy, lean in for a better look, and suddenly it's like trying to see through frosted glass. The sources are really clear. Dew is a major issue that can cut your night short. And worse, over time, moisture isn't great for your expensive optical coatings, but thankfully, there are some really practical ways to fight back.
Okay, what do we got?
Well, one clever thing is a desiccant cap. Costs around $35 maybe. It fits into the focuser opening, usually comes in 1.25 and 2 sizes when you're storing the scope. It's filled with silica gel, basically. It absorbs moisture from inside the tube. This isn't just about dew during observing, it's key for preventing mold growth inside your scope if you store it somewhere humid. Really important for long-term care.
Ah, so that's more for storage protection. What about while you're actually out observing?
Right, for active observing, the classic solution is a dew shield. It's basically just an extension, like a long hood, that fits onto the front of your telescope tube. It creates a boundary layer of air and physically blocks dew from settling easily on your main lens or corrector plate. Simple physics, but often very effective.
Okay, physical barrier.
Exactly, but if it's really cold and damp, sometimes even a shield isn't enough. That's where dew heaters come in. These are typically flexible bands with heating elements inside, often powered by a USB battery pack or a dedicated controller. You wrap them around your objective lens or maybe your eyepiece or finder scope too. They gently warm the glass just a tiny bit, just a few degrees above the ambient air temperature. That slight temperature difference is usually enough to completely prevent any condensation from forming on the optical surface.
Active heating. Okay, that sounds pretty effective.
It really is. So combining these things, the shield, the heater, the storage cap, means you can observe for longer, even in challenging conditions, and you're protecting your gear. It's about maximizing your time under the stars.
That's brilliant. Really practical stuff to keep the view clear and protect your investment. Do people often use, say, a shield and a heater together?
Oh yeah, absolutely. Very common combination, especially for Schmidt-Cassegrains or refractors, which have glass at the front. The shield provides that first passive defense, reducing the load. Then the heater provides the active guarantee, especially if it's really dewy or cold. The desiccant cap is more the put it away dry step. So yeah, you can build up a whole anti-dew system.
Wow. Okay, what a tour. We've gone from something as simple as a red light, protecting your night vision, through finding things easier with better finders, getting more power with Barlows, getting those amazing immersive views with better eyepieces, and finally, literally battling the elements with dew control. It's so clear. These aren't just like optional extras or gadgets. They really are tools. Each one seems thoughtfully designed to solve a specific problem and genuinely, as you said, transform the viewing experience, making it easier, more comfortable, more rewarding.
Absolutely. That's the core message from all the material we looked at. When you understand these accessories and choose them strategically, you really move beyond just basic viewing. You optimize what you can see, you improve your comfort, you reduce frustration, and you end up connecting with the universe on a much deeper level. It's all about empowering you, the observer, to get the absolute most out of every single clear night you have, turning those potential struggles into moments of real satisfaction and hopefully discovery.
Making the most of every night under the stars. I love that.
So as you think about maybe which of these tools might be your next step, your next stargazing companion, maybe reflect on how each little upgrade isn't just about a better image. It's also about maybe building your patience, sharpening your focus, deepening that appreciation, and ultimately just strengthening your own personal connection to this incredible, vast universe out there. It's an investment in wonder itself, really.